This is a quick video of TinLethax on investigating hardware device on Lenovo YogaBook. So as you can see here, I'm currently running Debian 10 from someone that I'm not really know who is Jacob. I'm not sure how to pronounce his name, but he made Linux possible on YogaBook. So I do some investigation on i2c devices. This device is very weird device. You know, it have pretty unique looking. It had red color. I really love the red color. It has a different profile from other tablets and laptops, and it also has a weird hardware. So let's take a look here. So I just tracked down almost every device. So on i2c-0 we have BQ2754 address is 0 by 55. This is a battery charging device. I'm not sure how to read this. A PMIC controller for charging batteries and handling USB OTG power. Is kind of like a power delivery in USB-C, but it's different. Next thing is the DRV2604/0. The address is 0 by 5A. The DRV stuff is model driver. It had two of them on different i2c bus. They can't change its address, so engineering comes in play. They need to put two devices because no haptic feedback of this Hello keyboard. They need to use another i2c bus to put another model driver. So as you can see on this touch screen, very cool. i2c-0 we have a first one, and i2c-3 we have the second one. Okay, just the next one on i2c-0 RT5677. This is what other PC use, but mine PC is quite weird. On Lenovo YogaBook is use a different hardware ID. Instead of the RT is use a 10EC5677. So compiling a driver need to take a lot more time to investigate on the device, finding the actual name, and messing up around with the kernel stuff that I'm currently gonna working very soon for only to make the sound works. The address of the device is it's not focused. Okay, it's focused. Is 0 by 3B. Move to next bus i2c-1. We have GDX 1001 is actually a Goodix Hello keyboard. Our Goodix Hello keyboard has address is 0 by 16. STH9310 on the part number is SX9310. This is a very weird device again. This is called SAR human detection device. It can detect the human by using a capacitive stuff like your touchpad or your touch screen. And my dad told me that they need to put this stuff into this PC because at the release there is more aliens than humans, so they need way to detect a human. Just kidding. So STH9310 has an address 0 by 28. I have no idea what this sensor is used for, because it's kind of like human detection. It's maybe some sort of, when I touch the case, the housing the chassis around, it can detect that human is touching and they do something like start some services when they're running, when my YogaBook running Windows 10 or something that I don't know what it's for. I take a look, I I look at the data sheet and it says it can use for detect human and host device can change behavior of uh, transmitting a radio wave, some kind of that, to avoid healthy harm to never mind. Let's jump over to the i2c. So we have OVTI 2740 or OV2740. This is OmniVision's camera sensor. We have i2c address 0x0C. I'm I'm not I am not to mess around with the camera. First, I want the sound to work because I barely use a camera. It sucks, and I don't know why I need to use them. I don't even need them, except the front-facing camera, which is we'll take a look right now at the i2c-2. Next thing is Intel GPIOs. I'm not sure what is this. INT 3477. We don't know address because it can detect. I use i2c detects from i2c-tools. It can only detect. So I will show you folder in sys/sys/bus/i2c/devices. On i2c2 is exit to device, but I can detect. So let's show you for somehow. So on the bus number 2, hello, it's only detect 0C. It's only detect 0C, but the Intel device maybe it's out of range or use a 10-bit address or whatever, I don't know, and I don't care. What's the next thing? i2c-3. We have a welcome touch no welcome digitizer. This is i2c welcome digitizer, not a USB or serial. This is quite different. The same chip used in some of the Galaxy, Samsung Galaxy device. In my case, my dad, he has Galaxy Note 8.0, which is a tablet. It can use S Pen to take notes, and it's compatible with my YogaBook. Very good. Another tip for you who using YogaBook first generation. Of using side button and eraser, but there are only few of them supported, like from the old generation. Surface 1, Surface 2, or a Galaxy S Pen from 2013, 16, 2015, some sort of that. And there's a lot more like Stellar, Nolly, Digital, blah blah blah, something that I can't buy anymore. It works, but some of them sucks. But never mind. Okay, move to next thing. We have another the RV2604/1. This is the second model driver. It has the same address with the first one, as I told you earlier that they have a fixed address, so they need to separate two of them on the different buses. Very genius. So move to next thing. On i2c5 we have HDP0001. Okay. The address some kind, it has two address detected. It can be 6C or 6D or both. Same as Wacom. Sorry for not to mention that. It's at 2C and 09. Not sure. It can belong to other device that cannot be detected and cannot show up like this one, as you see that it has a name on it. I'm just put right there, so I can confirm a Wacom digitizer address and my touchscreen address. It can be somehow the EEPROM of my display. You know that VGA display port or whatever that connect from your laptop to the monitor. Inside the monitor it has an integrated EEPROM, which is i2c bus, and I had a secret project that I haven't told you guys. Sorry, my bad English. I put my sensor into the back of the screen of my old laptop and I can make it auto rotate. Just that. A project called Auto Orient on my GitHub. Okay, back to our subject. HDP 0001 address. I'm not sure about that, but something that I'm sure about that is it's made by Hisense. I'm not sure, it's a Chinese manufacturer, Chinese company making electronic stuff. Don't get into that much because this is just a general normal touchpad. It can do anything that ClearPad on my phone that made by Synaptic does. Okay, move on to the i2c. This is pretty weird, so I include my scan from the i2c detect. As you can see, it had a lot of addresses. So I'm gonna take a look here. Maybe I can realize what is what in this video. So we only see the i2c dash Intel INT 34D3. When I open up here, get into the folder, we have CHT the Blue Cove X charger, CHT the Blue Cove LEDs, CHT the Blue Cove power source, CHT the Blue Cove region. This might be one of these devices. I haven't taken a look inside yet. It can have i2c7 is linked to i2c. Just let them gonna make second part video. It has a lot of addresses, and it's gonna take more time to do because I'm gonna take a look later in the kernel. I already cloned it from GitHub. It's about 2.58 gigabytes. That's a lot of space that took. Move to the last one, i2c7. When I use i2c detect command, it can't detect, but I find out that it has something. It's a BQ25892 made by Texas Instruments. Oh, I forgot to tell you that this BQ thing is made by Texas Instruments. A DRV thing, motor driver, also made by Texas Instruments. SMT stop human detector, made by Semtech. GD Goodix is made by Goodix. Yes. This BQ stuff is a fast charger. This fast charger, 8.5 amp hour. If charging with 501 amp, it's gonna take, I don't know, to fully charge. But here I have original charger from Lenovo. It's capable of 502 amp 9V 2A and 12V 2A. Maximum is 24W. So this little device, a 3x3 bulk grid array device that handling fast charge. I still open this tab about this pretty cool device. This is a i2c control single cell 5A fast charger with max charge technology for high input voltage and adjustable voltage USB on the go boost blah 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 blah. First of all, this video is not sponsored by anyone. Just that. His sponsorship. So it had two parts number. One is ending with 90 and one ending with 92. It has a difference on spec, like a current, a maximum current, a lot of stuff. i2c address. I have a lot of. It's not focused again. I hope you can see it. It's have a lot of stuff. You can see here. It has stated output on the different on the pin 24. This had this select, but this is not connected. Blah blah blah. I'm not dig into that. And USB detection is different. Mine one is use a P-cell and OTG method. But never mind. Not take a look at that. So the address is 0x6b. You can see it here. 6bh. It's not focused. It's not focused. Oh no, my mobile phone. 6bh or 0x6b is a hexadecimal number. I have seen ending with h in my good display e-paper datasheet. It's confused me for some reason, but it's just I just know later that it's telling that this is a hexadecimal number. So okay, ending this quick video to show you a possible device that I can find within less than 30 minutes. Still have to do more, but I still have a next project currently running. A flex watch. Here as you can see, it's good display is a e-paper seller. Order from China. I'm doing about a flexible watch based on STM8L 8-bit very cheap microcontroller. And I'm also working on school project that about smart farming system that nearly the end. Kingdom come, not whole thing's gonna break down, but never mind, it's more than 50% finished. So I hope that my next project can be on YouTube, and I will see you guys on next video. But I will tell you something before this video will end. Upcoming video is about reviewing this Lenovo YogaBook. It's about in-depth review using Windows and Linux, and I will show you my Lenovo YogaBook. Goodbye guys.